you know.
Hi and welcome. I guess you're now recording, but Betsy, do you want to, for the recording's sake, do you have something you want to say?
Uh, Good afternoon, everyone. Welcome to the CARC Workforce Development track today. Today, we're going to hear from two of our NSF SCIPE awards on their programs themselves, the challenges they've had, and then we'll open it up to discussion as we go along. First up is Winona from Indiana University.
Hi, thank you. So I'm here representing a joint university, three university effort, Indiana University, Purdue University, and Mississippi State University. I'll be talking about our project called CI Pivot. The name is meaningful to us, so hopefully I'll get to that in a clear way. But first, okay. Nope. All right. So I like to have an agenda. So, first I will just talk a little bit about the overall project, then, what we're doing with the award, and then some more particulars, and hopefully have some good conversation at the end about future directions and interests in the area. But first, so I did this at my last invitation to CARC, but I think this is a different group of folks. So I wanted you all to guess the prompt. So I used Google Gemini to help generate AI. In particular, Gen AI is all the rage at our institution. We love AI. So guess the prompt here for the generation of this image. No takers? Betsy, you can't participate. You
I
already
know.
know.
What's the difference between an IT professional and an RCD professional?
Roughly, that's roughly correct. So good job on that. And the reason why I really like this slide here is like this didn't take a whole lot of prompt engineering. This was just a single, I didn't have to say, make Google, I need you to contrast, workstations and, compute racks and put domain scientists in this one and, things like email and application, office applications in the other. It was super simple prompt that really, to me, shows something interesting about the times we are in, because it is, CARC is a professional organization, and this kind of shows like just how well CARC and other groups are working. It's now sort of in our internet literacy about what a research computing and data professional is doing, and some of those differences that can exist between at our university, we call them IT pros, but they're sort of endpoint management system or enterprise IT professional. And I thought the first time that I did this, it didn't go as well. And so this is to me a great thing for us in our community, in that we are, you know, explaining ourselves in a way that at least Google Gemini is recognizing, which can feel very difficult, at our own institutions. Okay, so okay. So in this one, I guess this one's a slightly more complicated prompt, but anyone I can call on the audience. What do you think the prompt was for this one? Yeah, I'm looking at Eric Collins.
You're on mute.
Yeah, I know. I'm trying to guess. It's such a very wide variety. Like the person with
Yeah.
the construction hat and the reflector vest, to the person with the whiteboard. Yeah, just it's like a collaborative, a multidisciplinary collaborative environment of some kind. I'm imagining.
Yeah, exactly. A little more specificity there. So what I asked it for was, yeah, show me, what an image of an economist, a geoscientists and a engineer working together with a CI professional. And this is what it came up with, so the hard hat's cute, right? That's not the kind of engineering I meant when I didn't specify. And,
Right.
the geoscientist is totally prepared to go like on a volcano,
Yeah.
she's ready for this. Again, so this was just a little more fun because this one's a little more connected to the project that I'm talking about. So full disclosure, Eric is a project partner, so he has a little heads up of the things that I'm going to talk about. So our award is, like Betsy said, one of a series of National Science Foundation supported projects, meant to innovate in the cyber infrastructure professional area. So our award is really focused on bringing capacity to our institutions to better support researchers on campus, and also in the national community. The way that we are doing this is, each one is different. You'll hear from a different project that has a totally different approach. This is great. So our approach is to recruit, train, and then integrate domain science experts into the cyber infrastructure professional ecosystem at our institutions and in the national community. I bet you can guess what our target areas were. Social behavioral economic scientists, represented by the economists with the blazer and the clipboard, the geosciences and engineering, although instead of hard hat type of engineering, we were envisioning something more like people who do computational fluid dynamics or electrical engineering that are typically sort of desktop MATLAB users that are failing to advance their work on their desktop quickly enough. So the premise of our award is just to restate that, is to identify and recruit domain science experts to equip them with the computational skills that they need to improve our institutional capacity to support that type of research on our campuses and nationally. So a little bit about our project. We kind of envisioned another twist on this is that, one of the things that we wanted to do was be able to have a bigger impact by having more people recruited, employed, trained, and deployed into our campuses to support research. And so is kind of represented here in this this Gantt chart timeline. So we had envisioned roughly 3 cohorts of individuals that we would, recruit and train and deploy. So we actually have some folks here that are joining us from both the first and the second cohort of our project. So thank you for your participation on this. And some of the activities, are just exactly like what I've been talking about. People are identified, recruited into our centers. We form a cohort. So these folks are working across our institutions to learn from each other and potentially even, support each other's researchers when the need arises. So we have, in addition to those sort of employment sort of cadence of, every 18 months doing a hiring cycle, we are also doing some other types of activities. So we're doing at the start of the project, which is actually sort of extending, into latter parts of the project, we have called listening tours. And basically these are just, opportunities for faculty to talk to us about how they envision, in their ideal world, how do they envision somebody who's employed at the university working for a centralized research computing entity, wherever it is, to interact with them? And what are the types of needs that they are envision having addressed in partnership with that individual? So it's been very interesting, and we will be hopefully capturing some of those into an upcoming PERC paper. But it's very polarized. It's all over the place. Those of you who've been, in this RCD workspace for a long time are super familiar where sometimes somebody just wants you to come and fix their code. And then other folks really want you to understand that just getting a code running on a big machine is not sufficient. It doesn't just need to run, it needs to run and give you the right results. And you need to have some kind of knowledge of the domain in order to make that goal happen. We also are doing what we call future creating workshops. So we were really lucky last year to partner with the Internet 2, RCD Nexus Day, and CARC, of course, as part of that, to offer a community development activity. Again, just trying to understand the work, from different perspectives, what's needed to advance our workforce, particularly for early career individuals. So in this project, we recruit early career folks. So just having graduated from master's, PhD, something like that. So they have lots of domain knowledge, but maybe not necessarily the full complement of computational skills that your 10-year experienced person would have, right? So everybody comes with their own perspective on what's needed to advance the development of an early career cyber infrastructure professional, including those early career cyber infrastructure professionals. So that workforce or that activity brought us into contact with 100 or so of our colleagues across the nation to gather different perspectives, and we were able to capture that in a nice report. So I know some of you were there. Thank you so much for your participation. I thought that was a great success. Another couple of things that we are doing. So we have these collaboratory co-envisioning retreats, which really are meetings that are in person, meant to build the cohort, and we rotate those in the Indiana sector and the Mississippi, since we've got three. Indiana University and Purdue University are only about 2 hours apart, so we tend to just do one for Indiana and one for Mississippi. But those are opportunities for the cyber infrastructure professionals to get to know each other, and to really work on advancing their careers in the way that not just learning new skills, but innovating together, to give them that opportunity to be in close proximity, to bounce new ideas off of each other, not just 30 minutes on a Zoom meeting, 1 hour in a Zoom meeting once a month, but deep work together to innovate. And so the idea there is that this regular contact is meant to build the cohort, but lead to these things called these collaboratory carpentries. So that's the bottom thing on the project timeline there. And those carpentries, we were inspired, of course, by the carpentries in the work that they do. They build composable trainings that you're able to take pieces, open source, deliver it to the community, or just use it for yourself. And so that's a goal for each of these cohorts, to be able to deliver a carpentry of some type, at the end of their cohort period. Okay. So just on the bottom is a little, our vision for, you get this wonderful opportunity from the National Science Foundation to hire whole people, not just like 12% of somebody, to do something great. So what is it that they're doing? And this model probably looks a bit different than the usual expectation for a university. But first there's like the sort of usual day-to-day kinds of stuff. If you have a research computing at your institution, what you get is a lot of questions. These might be, coming in through email, but, at our institutions, we have a ticketing system. So a lot of this is answering questions, sort of by learning by doing, answering people's questions. So those are the sort of day-to-day activities that everybody's super familiar with. Another expectation. So where this is, why the time is divided in this way, where we also have them doing, a deep engagement with the faculty, is that the cyber infrastructure professionals, and we call it very intentionally cyber infrastructure professional, as opposed to a facilitator or as opposed to a research software engineer, because the work is kind of in between those two spaces. If you're familiar with the history of facilitator, coming out of South Carolina and the ACI-REF definition of what a facilitator is kind of not, we are in that in-between space where, yes, a big chunk of the job is definitely to facilitate usage of the system by offering trainings and, conveying knowledge, but it's also to work very deeply in partnership with the faculty, more like what a research software engineer would do. So that can involve things like writing new code or doing, working on some analysis pipelines or even porting code. But it's really, that kind of work depends on the faculty group that we're engaging with at the time on campus. And the last chunk of time is one of those things that was required by the solicitation. So in the solicitation, at least in our cohort year or our funding year, they call it the Computational Science Support Network. And really that was attached to the Access program and support, basically being an extension of Access support, but in a community source way. Okay, so our philosophy here kind of can be, and our approach can kind of be encapsulated in these two different figures here. So figure one, we just pulled from our grant, and this is how we're envisioning the career trajectory while we have our cohorts. So they start out by coming in, whatever point they are at, a trained domain scientist with some amount of computational savvy, but not necessarily having, a vast, deep experience. And they're first, they are first embedded within our groups. At our institutions, they're answering tickets, they're learning how our system works, how the Access systems work as part of that, that computational science support network. And then the idea is that, okay, we've got to get them, comfortable with these systems and facile enough to be able to work directly with a more senior member of the research computing team, to help support research on campus. And then as they progress in time, they are then able to collaborate directly with researchers, independently. And in the last phase, they are, co-creating both with the researchers, but also with each other, so that they can, do things like deliver those collaboratory carpentries that I mentioned. So these are sort of done in phases. And then the way that we are doing this is they're supporting this timeline. It's fairly aggressive. It's an 18-month kind of timeline. And again, our goal was to hire domain scientists, not necessarily, definitely not computer scientists. So we weren't sure entirely what skills it was that people were going to come in with. So we kind of thought that we should do a flexible training pathway, if you will, here, which is conveyed in the next figure. So we identified, some relevant skills, to each of those phases there. So, oftentimes researchers, or not research, people come into these areas having, done some domain specific types of computational methods, like maybe, but they're not necessarily familiar, like having deep familiarity with Linux. They'll have a lot of Python, and maybe they have a couple of applications that they're really good at using. But they aren't necessarily aware of things like that we do as professionals, like the security and data practices that are sort of done across the university and that need to be instantiated, at that level, not just at the level of the individual researcher. So we build out these training plans with their direct supervisors' input and their input on where they are, to equip them with all these things that we think are needed to be effective cyber infrastructure professionals in the way that we have envisioned. And obviously this is part of the, the innovation of the award here is, this isn't necessarily the right way to do things, but this is one way that we are investigating, and that's part of why this is, instantiated as a research project, because we're learning new things. So this is how we've conceptualized it, and I'm pleased to report that we have roughly completed our first cohort of hires, and we were all able to write a paper together, and that it has been accepted at PERC. So I see some of the fellow authors and contributors on this call. Thank you so much. Very much looking forward to the community's reaction and our next steps on that. Okay, so another way to kind of think about, what we're trying to do in our award, and I'll try not to gobble up all the time, is really what, I kind of like to think of as a personal transformation. So this is just another lens at sort of looking at what we're trying to do, is we are hiring people with that scientific expertise, with the belief, the hypothesis that a good, robust research computing organization, needs to have a deep appreciation and knowledge of research processes and pressures on researchers on campus, so that they can bring that knowledge into the operations of our systems, which is typically done by folks with intense computing backgrounds and not necessarily a research background. So I really like this slide in that what we're trying to do is shift the person, from a user to a builder. I like that. From moving, my solo work to work at scale. So that means scaling things up, compute-wise, but also scaling the impact that you have at your institution. And then shifting it from, I have problems to solve, to I'm a solution maker. So I like this slide because I find it to be, inspirational and aspirational, and hope that my cohort here that's in attendance can recognize some of themselves in this and the powerful things that are happening even as we speak. Okay, so I've already talked about these. These are just our specific activities, but I wanted to highlight just a couple of things, some great things that are happening. So again, part of our conceptualization here, we've got 3 cohorts. Well, what happens to the people after the cohort? And so our initial envisioning was that, we're gonna hire great people. We're gonna equip them with some skills. Mainly, they're gonna equip themselves with skills with our support, and their value, their impact is going to be so well seen on campus that we will be able to, move them either to a position that's sort of co-funded by campus or into our own teams, because they're operating at such through a vacancy that has become open, and they're operating at such a good level that they just naturally able to accept the sort of higher level work that is opened up. And so I'm very pleased to report Trevin, who's here, has a position on campus largely funded by NOAA. Really awesome. He worked super hard, really demonstrated, how valuable this sort of learning trajectory is, and is, contributing to the greater good for science. And same thing for Ibrahim, moving on to, a more senior position within the research computing at Purdue. So congrats to those 2 who are really our first 2 graduates, if you will, from the CI Pivot project. Just to shout out to some of the particular things that these folks enabled. There was really there was a cross-institutional effort to get WRF installed, in different areas, but all across our 3 institutions. That's kind of a big deal. There at IU, we were one of the main things that happened was that we were involved in, from the ground up, of creating a data hub for researchers on campus to be able to, in one place, discover these core environmental data sources that the university had, but in a way that's approachable and, wasn't them having to source every single thing for themselves and have a copy themselves in their own local space, but really making these really valuable data sets easy for the researchers to find and use. And then huge shout out to Mississippi State, who, major impact there. Through all those, outreach efforts that Trevin was involved with, the number of unique users and more than doubled. So in the time that he was there, so huge shout out there for that. So I will go ahead and stop talking to give space for our next group.
Thank you, Anona. Do you want to share your screen, or do you want me to bring up your presentation?
Oh, Betsy, I can bring it up if you like. I wasn't sure if there was
Okay.
time for Q&A for Winona, or did you want to just dive in?
Let's dive in, because I want to give you space to talk, because I'm really interested in hearing about your award. And then we can save questions for the end, or people can post them.
That sounds
And
good.
folks that are if you want to post questions, please do so. And we will follow up with them. And this is being recorded and will be sent out, because I've had requests already for people that were unable to attend.
Okay, that sounds great. Let me bring up my screen.
Thank you.
Hopefully you can see it.
Yep.
Let me see. And you can see the screen share view now.
Yep.
Awesome. All right. Good afternoon, everyone. I'm Vandana Janeja. I'm a professor of information systems at the University of Maryland, Baltimore County. I'm also associate dean for research in our College of Engineering and IT. I also have Roy Prouty, who's a team member. He's here, and hopefully he can chime in at some point as well. So you'll hear from him as well. So I really wanted to bring in a flavor of a couple of different projects that converged into our SCIPE project, and how the ecosystem is developing for sustained science, especially, developing some of the pipeline for undergraduate and graduate researchers, and also our cyber infrastructure professionals. So the reason I'm here today is really because of this project, which is our SCIPE project. And it's a collaborative project between UMBC and University of Maryland Center for Environmental Sciences, which is both are part of the University System of Maryland. But UMSCIS is really the hub for a lot of the environmental science research, and really studying the impact on the Chesapeake Bay. And so colleagues Victoria Coles, Andrew Elmore, Jin Zhang, they've been doing a lot of research for a long time. And then there were a few people who were hired through this grant. Xiaozhu, Birch, they both are 100% cyber infrastructure professionals that were brought over in this grant. Roy has a percentage split, and he's core, professional at the Department of Information Technology, but he was also 20% or so on the SCIPE grant, and the percentage varies from year to year. And both Setso and Slava, they both are also percentage-based cyber infrastructure professionals. So there's overall, there's a group of faculty members, and also Jianwu Wang, he's a faculty member in IS. He's also on this grant, and I'll bring up his reference in a little bit. So that's the core team, if you will. And the idea behind this particular grant was to develop a sense of this cyber collaboratory, where different transdisciplinary groups could come together and could be supported by cyber infrastructure professionals. So UMSCIS in particular has a lot of these environmental science researchers who would be ramped up with the support of the cyber infrastructure professionals. And same at UMBC, and Roy has been deeply involved with several of our projects supporting faculty members, and through a network of people that he works with and leads as well. The whole idea is leveraging high performance computing, cloud computing, open data science, scalable computing, and different aspects of that. So I'll dive into some of the examples so you see more specifics. So this is really a partnership between UMBC and UMSCIS. So UMSCIS doesn't have an undergraduate program, and there was a deep interest that undergraduate students who are trained at UMBC in data science and high performance computing could support the research of our UMSCIS colleagues. In addition, we already have a very well-established cluster, which Roy and his team manages here at UMBC, along with several others. And how could we bring that element of support for high-performance computing as well into UMSCIS? Now, on the UMBC side, in our SCIPE grant, we included a couple of use cases or example projects that would be supported through this grant and through the high performance support. One of them was an NSF HDR institute that I also direct, which is harnessing the data and model revolution in the polar regions. It's called iHarp. And the hope was that the SCIPE environment and the SCIPE support would also nourish this exemplar use case. So I'll give you an example of that project and also show you some of the other activities that we have been doing in not only developing the cyber infrastructure pipeline, but also developing a pipeline of undergrad students and graduate students who will advance the research. So what really is iHarp? So iHarp is a harnessing the data revolution project. HDR was one of the big ideas at NSF, and they supported 5 big institutes. This was the precursor to the AI institutes. And it has about 80-some collaborators across several universities. Some of them you see at the bottom. We have expanded these collaborations now. The whole idea is that a lot of the data has been collected in the polar regions. A lot of the models are already there, but not, AI has not been used to leverage the data and the models. So iHarp kind of brings data science and AI experts along with polar scientists together to solve some real world problems. And what are some of those problems? There's a lot of things happening on the surface of the ice, on the ice sheets, which is the North Pole and the South Pole. There are things happening within the ocean as well. There are dynamics happening in the ocean. The whole idea of understanding the polar regions is how can we inform the understanding of sea level rise? But all of these components play a role together. And the interaction of these components is equally important to understand. So bringing in physics-driven machine learning and AI, how can we advance our understanding of sea level rise? So for example, majority of our fresh water is situated in the Arctic and Antarctic. If these melt, the sea level rise can rise drastically, but the models have a lot of uncertainty in them. So how can we improve the model understanding? How can we improve or reduce the uncertainty in the model prediction of sea level rise? So we have to look at things like what's happening on the surface of the ice sheet. Are there lakes forming? These blue things that you see here are lakes forming. And as you can imagine, there is tremendous amount of AI modeling needed, computer vision modeling needed to address this problem. And we've done some machine learning challenges and data challenges to address this. Large amounts of data again. Glaciers are calving, glaciers are moving, and they are breaking off from the ice sheet and going into the ocean. That directly leads into sea level rise. So how do these break off? How can we interpret these images? And what are the models that are at play? We look at the under ice sheets as well to look at what are the layers under the ice. Like it's almost like tree rings that tell you the age of the ice. So you could actually trace it back to ice age, and it'll help you understand the climate modeling. So essentially, you want to get to an ice layer annotation all the way across several images that are taken through radargrams. So there are several others, digital twin models of the Earth. There's also a deep understanding of the ocean and so on. So the complexity is very large, as you can see. So this was an exemplar project in SCIPE. And one of the first things that we did is really bring in cyber infrastructure professional support to tackle the large data sets and to begin using HPCs. And I like to share this example that one of our students, as an example, had never used Linux, had never used high performance computing. And Roy very carefully worked with the student, and then subsequently his team also started working with our students. And this one particular student, she did this digital twin project as well with colleagues at NASA, and she did Greenland wide scale projects eventually, and now she's an assistant professor. So the whole cycle was very fulfilling to see how a student who had never used high performance computing, through careful support and assessment and hand-holding to some extent, was able to not only learn these things herself, but also train others now. So that was a direct outcome of the SCIPE project, where the cyber infrastructure professionals really supported the students. So I'll talk a little bit more about how these pipelines are working for students. There are several other things that we have done where we use similar pipelines and support students to advance interdisciplinary work. And one direct offshoot of SCIPE and collaborations through SCIPE is a new project which was launched last year, which is for collaborations on AI and geosciences. It's a program through NSF Geosciences for bringing in AI and geoscientists together. So a lot of this work that we are doing is to bring environmental scientists, geoscientists together with high performance computing support and data science and AI support. So the core idea of our philosophy at UMBC was to support all types of disciplines. Oftentimes you might have a computer professional who knows all of this work already, but what about the folks who have never seen this type of technologies or have never worked on high performance computing? So that's the core philosophy of supporting all types of disciplines. And these are the two programs. I don't expect you to read any of this, but I just wanted to put this up there. I'll put some links later on for our programs. But these are the two programs that are sort of the flagship programs, if you will, for workforce building. One is the Data Science and AI Scholars Program, which is for undergrads. And we've recently launched Cyberinfrastructure Professional Program, which is a graduate program as well. So for the Data Science Scholars, we partnered with several centers that provide professional development support and University of Maryland Center for Environmental Sciences through the SCIPE program that directly pairs students with researchers. So students from UMBC can go into social science related work. They could go into environmental science work. And all the students get some mentorship and professional development support from these centers as well. So with this, we've been able to touch many disciplines across information systems, environmental sciences, GES, and so on, language, literature, and literature and culture, and even art. Art is not listed in here, but I'll show an example of art. And many of these students, they take data science and handle how to analyze data and take this into several of the domains. And some of these students have gone on to graduate school. Many of them have gone on to internships in the federal space and so on. So they've shown some really strong outcomes. So the DSS program initially was, predates SCIPE. It was launched in 2021. It was funded through an EDU program. And then subsequently, SCIPE has funded several of the scholars coming out of here who are paired with our geoscience and environmental science faculty. We also have teaching fellows in this program that end up teaching in some of the classes. And we have a foundation of data science class, which is based on the UC Berkeley Data 8 model. And we adapted that at UMBC through an NSF grant. And our data scholars go into this classroom to speak about their projects. And every year, because of that panel that we do in the Foundations of Data Science class, we get more students coming back to the Data Scholars program. So it's become this very nice feedback loop where we started with an initial cohort. They went and presented to the class. More students were interested. They kept coming back. And we've crossed, close to 45 or 50 students in the overall cohort. And just through SCIPE, we're supporting 4 or so students this year. So that has become a feedback loop of sorts. Several of these students go on to present at our undergraduate events, and we actually attracted a couple of high schoolers as well into this program. And since then, we've started having high schoolers since the last few years. And this year, we have 2 scholars working on SCIPE-related projects. Both high schoolers, one is working on wildfires and how they propagate, and another student is working on an LLM chat engine for supporting the community around environmental risks. So a lot of interesting projects are coming up as well. Another interesting example I wanted to share is it's not just a traditional use of computing to solve a problem, but it's also for outreach and dissemination and how do we reach the next generation, if you will. So we had a data scholar. She actually made a game with a penguin, on a iceberg, and how do you track the penguin, and it kind of relates to our glacier tracking project as well. So this was very interesting, and she's presented in multiple places. She went on to do her master's, and she's still a master's student now. This is our latest cohort of students. One of our students, for example, is now looking at sea ice and land ice interaction and massive amounts of data. This is being implemented on our HPC cluster. And the top 2 students that you're looking at are students who are working directly with UMC's colleagues and working on problems in the Chesapeake Bay or projects in the Chesapeake Bay. And the left corner is not a Skype project, but it's still a fun project to consider, which is a deepfake detection project where a student was helping us with, unraveling the policies around deepfake detection. So students come from all kinds of walks of life. So the deepfake student is actually a public policy student, and so on. This is the art example that I mentioned where several of these students, Toby Williams was a scholar along with some other faculty members and researchers. He supported development of a ice cave or components of the ice cave that is now an exhibit at UMBC. And this was a collaboration between art and technology. Artists were creating these drawings, and then the rendition was being done by some of our computing students. And this kind of a cave environment is currently as an exhibit at UMBC. So this shows an interdisciplinarity outcome as well. This year, we've launched the UMBC Cyberinfrastructure Professional Graduate Fellowship Program as well, where the idea is the student is working with the PhD advisor on their existing research. But then the HPC mentor comes in, such as Roy or Jianbu, who's my colleague. They come in and they support these students on the HPC scaling of their projects. And then on our side, we are supporting them for mentoring, keeping coordination between the groups and making sure things are flowing smoothly and just keeping them on track. We actually have a presentation tomorrow from all of these students as a mid-year check-in point on how things are going for them. So these are some of our scholars, and you can see the breadth of the areas that they work in: environmental engineering, geography, environmental sciences, biology, multiple environmental engineering as well. So just continuing this support, we have realized that there is a lot of trust building, and I'll come to those ideas as well, but there's a lot of skill building as well. So we have created a series of technical AI workshops that run through iHarp, and then the center that Roy supports along with Jianbu has a series of workshops on HPC as well. We also do something called as Vice Bites, which is really professional development. So how to support students in public speaking, how do you support them in writing strong papers and presentations and so on. So there's a multiple sets of support that we provide in terms of workshopping and so on. We also do faculty workshops. So several of our UMC's colleagues and some of us have collaborated to host these faculty workshops. So here I think you see Birch presenting at an IMET conference where several of the faculty members came in from UMC's and some from UMBC. And then we have done something at UMBC with our social science, Center for Social Science Scholarship as well. And just in the interest of time, I'll share a couple of things. Our UMC's colleagues are especially spearheading this idea of supporting researchers on campus. And this is part of the newsletter where we share stories. For example, some of our cyber infrastructure professionals are supporting projects that researchers are bringing up to them. Since Xiaozhu and Birch are 100% supporting these types of ideas, they work more closely with faculty members and bringing up their projects as well, and Roy as well here at UMBC. So as I mentioned, the most important thing that I have picked up from here is that it's important to build trust and dialogue across these disciplines. Oftentimes, we don't even brand these as a computing project. We just brand it as something coming from CS3 or something coming from UMC's, and really trying to build that trust and connection through these centers and really going after intentional engagement. And if we are dealing with the data, we really respect the data owners and stewards, because we are trying to support them and not say, computing is going to solve every problem. Like in the case of polar science, it took us a long time to convey that we respect the data owners and stewards, and we are supporting their advancement, the science advancement. And then another thing that we have recently picked up, and our SIPs actually meet together, and the faculty members are not there, and it's really the SIPs talking to each other, and they bring back things that we need to support them on and supporting their career trajectory as well. The one challenge that I would say for some of these roles is that not everywhere these are institutionally supported. Like the roles for Xiaozhu and Birch are supported by SCIPE, and there's a hope that these would transition to institutional support. And Roy's luckily time is institutionally supported, but I'll let Roy speak as well on his impression of the support from the SIP side. So I'm going to pause and stop sharing here and see if Roy wants to share from his perspective as well.
Hi,
I
everyone.
don't know, Roy, if
Sorry,
you
I'm joining
want to-
from Baltimore International Airport, so there's a little bit of background here. Good to see a few of you again. So I just want to underscore some of what Vandana said about the importance of the SIPs being able to meet and discuss some of the pain points in bringing IT professionals to be research computing professionals. Our ability to meet and talk about how the different domains have different focuses and different needs has been certainly eye-opening for me over the last year. And I think continues to do good work bridging the gap between domain science and our research computing professionals. I'm happy to answer any questions or maybe talk more on anything that Vandana might guide me on, but happy to be here. And I think that presentation that Vandana shared was fairly representative of the work that we're doing here.
And I should say, Roy is probably being modest, but he has single-handedly supported a bunch of research at UMBC and made that successful. So I think that partnership is very important between the researchers and cyber infrastructure professionals. And like Roy said, we are happy to answer questions as well.
What an amazing project, though. I am so impressed. It's one thing after, and the impact that you have in students and early career people is phenomenal. I'm just really impressed. Thank you. Do we have any other question? Do we have questions? And I see Scotty's joined us, so he's also another awardee that maybe we can guilt into presenting next month for us or something.
Happy to. I don't know about next month. I'd have to look at the calendar, but I would be more than happy to get on your schedule. Yeah.
All right, Michael, I think we just got our another.
Awesome.
See how I am? Do we have any questions? Roy, I have one quick question. So is your role then, do you get the request and then you kind of coordinate the people, the CIPs? Are you that glue that holds the CIPs together to get the coordination of projects and training out? Is that your role, or did I kind of misunderstand that?
So I think as the process matures, or like as our office matures, someone in my office would be providing that glue, making sure that university professionals, either at UMBC or UMCs or both, are ensuring that work continues to be done. But really, for now, I think Vandana mentioned that there are some folks, some program staff that are ensuring like appropriate cadence and making sure that people get together and stay on track. This being just a fraction of my time, it's a nice way to say it. It's been great to have program staff telling me what to do and how to support these different research needs.
I
Does
have
that answer
one
your
other.
question?
Yeah, it does.
Yeah, okay.
I have one other question. I don't know who it belongs to, but since you are a cross-institutional project, what is your trick to staying in step? And the reason I ask that is because, I am the liaison for Purdue for our SCIPE award, and Winona and I try like extremely hard to stay in step. But since our universities are so broad and, and then to add Mississippi State's just another, like, what's your trick in the way that you're staying in step, or are you? Is that one of your challenges? And an example for us is like we talk to our CIPs and we try to deliver the service so our CIPs do exactly the same across the institutions in certain things. And that's been really challenging to get that to implement across all three institutions.
Yeah, and I will say some part of the logistics is regular meeting cadence is very important across the teams. I'm sure you've seen that as well. So that one weekly meeting keeps us on track for the SCIPE. But then we have separate meetings with the program staff regularly on our end. We have something called, I like to call it as an ops meeting that I have with some of our program staff. And then Roy runs this meeting together with SIPs as well. And then for bigger projects like iHarp, we have regular cadence as well that we rotate every week. That one week is an operational meeting, another week is a presentation meeting, a third week is a talk meeting, and so on. But then we have these side meetings as well. But just for the SCIPE itself, keeping the weekly meetings and the program staff ops meeting and the SIP meeting has helped us. Not to say that there haven't been challenges, and we don't always are in lockstep. We're not always in lockstep, but we give ourselves grace for that. I think like this, the SIP meeting was a little bit late to start, right, Roy? I think that was started more recently than the other meetings.
Yeah, it was, and I do think that SIP only meeting, not that we're like excluding other people from joining, but that SIP only meeting it's unstructured. It's just bring up what you want, and it helps us identify, like I said, those pain points or things that we're working on, or interesting ideas that a researcher has brought up to them that they've never experienced before, and so we have this nice, again, unstructured. I think is important just to allow us all to freely communicate and
Yeah.
like work with each other, because we are at different institutions, and the pressures on us are different based on those different universities. So having an unstructured time to talk about what's the topic of the day and what's the pressure of the day is certainly helpful.
Thank you. We have a couple minutes left. Oh, yeah, Scotty, did you have a question
Yeah.
or a comment?
No, a question. So in the presentation, you said we're hoping these would serve like broad domains, but you also really emphasize kind of geo and some of the earth sciences. Can you describe for us how if you're getting your cyber infrastructure professionals, whether they be the students or the staff, involved in the domain conferences? So this would be like AGU. Do they go to sessions at AGU or polar programs, similar things? Like how much are you sending them like deep into the science domain so that they just get immersed in the language and the behavior?
Yeah, so it's really immersive. A lot of our students go to AGU. They present at AGU. There's a Geological Society conference coming up. 7 or 8 of our students are going there. So it's a lot of deep connection. And in fact, in iHarp, every project has a hallmark that it must have a computing and polar science expert. So we try to enforce that. And then on the data scholar side, several of our data scholars have actually supported writing of these publications. One scholar, for example, supported a community event where they went and met with community as well and collected data from them. And the students seem to enjoy that a lot. They learn a lot and they appreciate that a lot as well.
Okay, we're at time. I want to take the time to thank everyone for coming. We will definitely queue up a few more of these because there are definitely awards in the community that we haven't heard from that we'd like to. With that, Michael and I would like to say thank you for joining. If you'd like to volunteer, we're always looking for volunteers. Michael, do you have any last minute?
No, I think that's it, and look forward to seeing you all next month.
All right, thanks everyone. Have a
Thank
great
you.
day. Take care.